Hello, dear students. This is Professor John Forsyth again. Today I'm going to show some more advanced things we can do with lists, which Chapter 4 also covers of the text. So let's start off with creating a simple list. And you may notice I'm using VS Code just to give some variety for those that use VS Code instead of PyCharm. So I'm just creating a simple list here with 4 numbers in it. And let's say I wanted to print each item in that list. So I could do 4 print statements since there's 4 items. I could say print my list and refer to index 0, which is the first item in the list, using the square brace syntax. So that will print, if I play that, that prints number 4. Here's a little trick too you might like to do to clear your terminal screen. If you type clear, we get a clear terminal screen. Okay, so and let's copy this because I want to do this 4 times for every single item. So there's 4, and I just need to change the index number. So there's the second item referred to by index 1, the third item referred to by index 2. So that's going to be the 2 here. And the fourth item will be index 3 right here, okay? So if I play that, it prints each of those things one at a time, okay? So if we were to like append something to our list, say we want to append the number 5, so we go ahead and do that. So now my list has 5 on the end of it. And if I want to print that 5, I need to go ahead and now update this and add my list index 4, which is that new number I just added. Okay, so now that will print all 5 things in the list. So this, you can imagine if you had a very large list, this is not going to be really workable. And if you change your list, as I did here with append, it's going to start to get pretty messy in your code and not very readable or maintainable. So let's make this much simpler. Python gives us a way to do that. It's called a for loop. And loop is kind of like, you could think of it as cycle or circle. It just basically means you're going to repeat or loop. We say in programming talk or speak, we often say loop, like loop over some things to repeat something for a sequence or a list of things. So Python has what's called the for loop, and its syntax is basically for, and then each item that you want to loop over, I could call it X, Y, it's my choice. I'm just going to call it item. Okay, so this is a variable that I'm choosing, and then we say in, and then the collection or list that we want to loop over, okay? So I'm going to loop over everything, all 4 numbers in this my list, and assign those numbers one at a time to this variable called item. And I need to put a colon at the end of my for in header. And then if I hit enter, VS Code, because I have the Python extension, is going to automatically indent this for me. So Python uses indentation to communicate what is going on, both to the programmer and to the Python interpreter, which runs your code. So I just want to print each item, just as I did before with the 4 print statements, and I can go ahead and play this, and it does exactly what I want it to in much less code, just well, 2 lines of code instead of 4. But if we had a very large list, you could imagine this is going to be very handy, a lot simpler to do something like this, okay? So just as a little side note here, if you are familiar with other languages or in the future have come across them, you will probably see this syntax. So instead of doing a colon and indentation, you'll do braces, and these braces indicate like where the beginning and the end of your loop is. But Python uses indentation instead of these. Some people like that, like the way Python does it, others don't, but that's the way it is. So we don't use braces, we use just indentation, whereas other languages will use both those like braces and indentation to communicate and be able to read the code. to see what it's doing and to communicate to the computer how to run the code. So let me show just the importance of indentation. Say I printed every number, and at the very end I want to print a message that says printed all numbers. So I naively will just say I printed all numbers. So there's my message. And if I play that, it will print the number and then give me a message that's inaccurate right now, saying that I printed all the numbers after each one. So the way I can change this so that it only prints once after all numbers have been printed is I need to unindent it and probably add a space for style. So that now I have a blank line, so this is visually separated. And if I run that, it now just prints that message once after all the numbers have been printed. So that's what the indentation will do for you. So anything that's indented, you could have many lines of code indented, and that would all be included in this for loop. That code would be repeated every time it grabbed a new item off of our list. Okay, so there's indentation for you. Now let's look at how we can grab a piece of a list and assign it to a different variable. So I can say I want to grab, we call this a slice in Python. So let's say I want to grab the first two items. So let's just say the first two. So now I can say my list, and I use what's called the slice syntax. So I'm going to use braces or brackets, and I'm going to say give me the first to the third. So I'm saying third, but this is index 2, so we're counting from 0, sorry, so 0, 1, 2. But well, think about what that's going to print. So that slice of these things off the front of the list, starting from 0 and going to 2, will now be stored in first 2. But let's see exactly what items that gets. So I just played that. If we look at the bottom here, it only grabbed the first 2 items, the 4 and the 3. Even though index 2 is the third index, 0, 1, 2, with the slice syntax, it won't include this index. It'll go up to that, but not include it. So that could be kind of unintuitive at first, but if you're going from the beginning of the list, you could also think of it as we'll grab the first 2 items of that list. But again, it's not including the item that's at index 2, because that would be the 2. We're only getting the 4 and the 3. Another way to write this, and I'm going to leave my print statement here. Maybe I don't like to use variable names that are inaccurate, so let's call this my slice, because I'm going to change things up. So, and we want to print my slice. And again, this is just another list. But let's say we want to grab everything all the way to the end, but we don't know exactly what the index is at the end because our list could be very large. So you can just omit the last index number. It will grab everything from the beginning, 0, to the very end. So if I do that, I get the full list, 4, 3, 2, 1. So if we omit the first item, it will default to the very beginning also. Just as leaving the index off of the second part after this colon, we'll include everything up to the end. Leaving it off of the beginning will include everything up to the beginning. So if we do that, that gives us the same thing, 4, 3, 2, 1. So that 0 was optional. Okay. Now let me show you why you would want to do this, because this syntax this type of assignment right here can be really useful. If I don't do a slice and I just do this and I print my slice, I will get the same thing, 4, 3, 2, 1. And I want to show you why that's useful. Okay, so I have, and actually, sorry, I like to be accurate. My Now let's just keep it, I'll just call it my list, or my slice still. It's not a slice, I can't handle it. Okay, so let's just call it X to keep it generic. So if I just run that, all I did was update the name of the variable. It prints the same thing. So now I'm using X as the name of this list, okay? So when you look at this, this may look like you are making a copy of my list because you're assigning it to another variable. But what's really happening is in the computer's memory, it's saying that X will refer to the same list. And as we saw in the last chapter and the last video, lists can be changed. So if I were to append something to my list, let's say we append the number 5 and we play this. Notice I print X here, but I'm changing my list by appending 5, but I still get that 5 printed when I print X. And that is because these two variable names are referring to the exact same list. If I were to say x.append and append a 6, what we're doing is we're appending a 5 to the same list as we're appending a 6 to. If I play this again, it now has 5 and 6. And just to show you that both lists are the same, let's print both of them. My list, okay? After we've appended my list.append 5, x.append 6, and then we print the X and we print my list, and they're going to print the exact same list because they actually are referring to the exact same list. But sometimes you may want to be able to change a list without changing the original. So in order to do that, you need to make a copy of the list, a true copy, not just a reference to the same list. So that's where this slice syntax comes in handy. Okay, so this makes a true copy. By using the slice syntax, I'm slicing the whole list and assigning it to X. And now this is going to change how the rest of this code works. So I start with 4321, I append a 5, and here I copied 4321, but then at this position I append a 6. So now I'm going to have two lists, one that's 4321 5, and another one that X is referring to, 4321 6, and that will show up in these two print statements. So let's play that. So here you can see how they're different. They're now independent lists. So this was a true copy right here, and that's another handy thing for the slice syntax. That's what that can give us. Okay, so there's some other built-in functions that can be handy in order if you're working with a list of numbers. Let's say we want to get the maximum value of this list of numbers. So I created a variable maximum underscore value, and I can say max and pass the list to max, and then I can print that maximum value. So there we go. Print that. So 4 is the maximum value of our list. We could also get the minimum value. Let's just call it minimum to keep it short here. So minimum value, so there's a built-in function called min, and I can pass it my list. And let's change this print to print the minimum. We're not using this anymore, so we can get rid of that. So now we have 3 lines of code. We create the list, grab the minimum of it, and print that minimum, storing it in a variable, and then we print that variable. So that gives us a 1. Okay. We can also sum a list of numbers, and there's also a built-in function called sum. So let's say the total of our list. I'm going to change this to sum, and we change this. We leave this the same. And now I'm going to change my print to print my total. Okay, so this will sum these numbers up together to give us 10. So if we play that, we automatically get the sum of that list of numbers. So we can also modify a list at a specific index. So if I say my list and I want to change the second item in the list, so again that's index 1, and let's change it from a 3, the second item, to a 5. And then we'll print my list just to show that it did change that list, the second item of the list specifically. Yeah, it's 5 now instead of the 3. Had to think about that for a second. Okay. So now another thing we can do if we want a collection of things that have an order that like a list does, but we don't want it to be possible to change it, then we can create what's called a tuple. So if I just change my code slightly here, I can say my tuple, and I will change these braces to parentheses. And now I have what's called a tuple. I can print that, my tuple, and if I play that, it shows my curly, or my parentheses and the 4 numbers inside of it. A tuple, as I said, is something that can't change. So if I were to later say in my code, for example, oh, I want to change the third item, so index 2, and I want to make that 0, and then I want to print my tuple afterwards. Python is protecting us here by using a tuple from changing it, if that's our intention. Because if I play that, I'm going to get an error. It says type error, tuple object does not support item assignment. So I cannot change something at a particular index in a tuple. I still can, however, access it using that same syntax as we use on lists. So this is going to be the third item inside of my tuple, and I can print that. So reading it is not changing it. I'm just reading it. I'm asking, using the syntax, what's at position, or index 2, the third item. So if I play that, I get the 2. So there's no changing here, no assigning to index 2. I'm just reading that value. So tuples are great if you want to read and keep your values the same without the risk of ever having them change. You can use a tuple, so that could be useful depending on exactly what you're trying to accomplish. Tuples can also be looped over, just like lists. So we can say for item in my tuple, colon, and I can print each of those items, just like I did with the list. So nothing different here, 4, 3, 2, 1. I can also loop over a string. So if I change this, let's just start clean here. So if I have like a word, let's say hello. Strings have an order. They are a group of letters starting from H, ending in O here. So I can actually loop over each letter in my word, and I can print each letter. My choices here were the variable names. I chose word to be clear that I've got this word hello. And then I chose letter here. But these were not choices. I had to use for and in. That's built in. I have to use that. But I can choose what the variable name is here. So I chose something clear to show that it's letters. If I print my letters, it prints them vertically here, H-E-L-L-O. Thanks for watching this video. We'll see you for the next lesson.